All right, so for homework, you had 2 steps. The first was pretty simple. If one solution to a quadratic function is 2 minus 5i, what would the other complex solution be? So that we just know, we use the fact that we know that complex conjugates are always solutions. So if 2 minus 5i is one solution, then 2 plus 5i would be your other solution. All right. So the second one goes multiply your 2 complex factors together. What is the quadratic you get as a result? Now be careful here. I'm not just asking you to multiply these 2 numbers together because these are the solutions. I want you to multiply them as factors. Okay, so again, as factors, what we do is we just put 1 minus the solution. 2 minus 5i times 1 minus 2 plus 5i. Okay, so you can distribute the negative to get rid of those parentheses. I would recommend doing that, especially before you distribute. It really doesn't change much. Okay, but like I said, it's a little simpler than trying to distribute and saying, okay, well, I distribute this 2 to here, but that's negative and that's negative. Nah, get rid of those parentheses first. Okay, so these are your 2 complex factors, right? And now we have to FOIL. Oh, I'm sorry, not 1.
Yeah, I was about to ask that just now. I was going to say, wait, didn't you tell us X?
Yes, I did. Those are supposed to be X's. Thank you. All right. Yeah, because I was going to start foiling. I said, no, that didn't look right. Okay. So again, I'm going to do it with my method, how I'd kind of line them up. I saw some of you implement that. Again, if you feel comfortable with it, continue to use it. If you like whatever method that you learned before, stick with that. So we have x times x, x squared. X times -2, -2x. X times -5i, -5ix. Now, when we do something like this, it doesn't really matter which one comes first. Usually the variable always goes last, so that's why I wrote it like this. I'm just going to rewrite it just so I don't take up so much space. X squared minus 2x minus 5ix. Okay, so that was the x. I distributed that. Now we distribute the -2. So we get another -2x. -2 times -2 is +4. -2 times -5i is +10i. So I didn't really talk about this yesterday, but just be careful. You can only line up things that have the same exact variables. So this is a 10i, so I don't have an x here, so I can't put it underneath here because those don't match up. All right, everything has to match up to make it easy. Then 5i times x, well, that's a +5ix. 5i times -2 is -10i, and things are looking good, like they'll cancel out. 5i times -5i, -25i squared. Now we simplify. There's only one x squared, so that's going to stay x squared. -2 plus -2 is -4x. These are eliminated. Plus 4. These are eliminated. Now this 25, -25, has the I squared there. So we have -25 times -1. So that's going to give us plus 25. And then we just combine those last 2 terms. And we get x squared minus 4x plus 29. All right, so that would be our resulting quadratic. Okay, so real quickly, before we move on, Right? If we look at the graph of x squared plus 4x minus 29, well, here we don't see anything. So if we zoom out all the way, my parabola is all the way up here. Okay, the vertex is at the point 225. So it's not even close to the x-axis, right? So you can see there are no real solutions because we do not cross the x-axis. But we knew that because we started with two imaginary complex factors. All right, any questions about the homework?
No.
All right.
No.
I put for the first question, I put the wrong answer. So I put it in like the factor form.
Oh, that's okay. That's fine. Don't worry.
All right.
You're good. Thank you for letting me know. I'll keep an eye out for that. Okay. So today we are going to finish the polynomial stuff. Okay. So what this all amounts to is we are going to write a polynomial as a product of all of its linear factors. So we're going to break down this polynomial to every part, including complex factors. All right, so we're going to add a little bit at the end on how to find the complex factors, but you already know them, even if you don't realize that you know them. All right, so what could be one of our first steps to start? Well, it's x to the fifth, so we can't use, the quadratic formula. Can't do that. So how can I get started, even considering what some of the factors are? Oops.
Graphing it?
Well, yeah, that's a good start. We can graph it. So let me punch it in. All right, so if we graph it, okay, we get this really skinny kind of graph. It looks like a cubic graph, all right, but we know that it's to the fifth power. So because it's to the fifth power, we know it could possibly have 5 zeros, 5 real zeros. We know that it's going to have 5 linear factors. So we should come up with 5 separate, x minus blah, x plus blah. Well, here there's definitely one. It crosses the x-axis at 2, -2. Right? So that's a great starting point. We also know it touches the x-axis at 1. So if you go way back to one of the earlier things we learned for this polynomials, okay, we have what's called a multiplicity here. This means x equals 1 shows up twice as a solution. All right, but we'll see that. All right, so we know we can try x equals -2 and x equals 1. So I'm going to write that down. All right. So yeah, graphing is a great way to do it because right away you get some definite answers. Okay, and luckily here, it wasn't some weird number in between 1 and 0.5 where you can't really tell where it is, right? Another thing you can do, which is gives you a little more broad spectrum, is you can use the PQ method. Right? Our first coefficient is 1. Our last term is 8. So we can come up with our possible roots, positive plus minus 1, 2, 4, and 8. And look at that. Those fall within those possible roots. So good start. Okay. So that would be our first step, right? So great. Find those. So now that I have one of the roots, what can we do? We can use... How do I break down a polynomial? Or how do I get a larger polynomial to a smaller polynomial?
We can use synthetic division.
Very good, right? You can use either division, but right. These are linear terms, so synthetic division sounds wonderful. I'm going to start with the easiest one, x equals 1. So just be careful here, right? You have a 1 here, but you're missing your x to the 4th term, so you need a 0. Another 1, a 2, a negative 12, and an 8. Oh, wow, that shot. I don't know where that ended up. All right, so a quick synthetic division. We bring down the 1. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. 1 plus 1 is 2. This gets us 2. This gets us 4. 1 times 4 is 4. Negative 8. Negative 8. 0. Good start. All right, so I'm just going to rewrite x plus 1. Okay, our root would be, or I'm sorry, our factor would be x minus 1. And this would give us 1x to the 4th. Remember, we dropped down the exponent. Plus 1x to the 3rd. Plus 2x squared. Plus 4x minus 8. All right, so now I could try 1 again, since we noticed it touches the axis, which means we have multiplicity, but let's say I forgot that. All right, so let's move on to negative 2. All right, so again, we just use our new coefficients. So I can just bring this down. All right, and we do some more synthetic division. Bring down the 1. 1 times negative 2, negative 2. Negative 1. Negative 2 times negative 1 is positive 2. 4. Negative 8. Negative 4. Positive 8. 0. So I have x minus 1. Now x plus 2. And what's left over is x to the 3rd minus x plus 4x minus 4. All right, so this is where now we can do a couple of things. Again, because we looked at the graph, we know that x equals 1 is another solution. But for now, let's pretend that we didn't know that. Let's say that we tried all of these, right? We went through 8 different synthetic divisions, and these are the only 2 that we've found. So looking at this, okay, we can use our factor by grouping because it is a cubic with 4 terms. Okay, that is one of the only times that you can use factor by grouping. This is a very specific method that we can't always use. So factor by grouping. So I'm going to forget about these 2 for now, and I'm just going to focus on this. So I'm going to rewrite it. Oops, I forgot a squared there. X squared. All right, so factor by grouping tells us to look at the first two terms by themselves and the second two terms by themselves. What can we factor out of these? What terms do our first two terms share? Well, there's no coefficient in the front here, but they do share a factor, x squared, right? There's an x squared there, and there's actually three x's here. So when I factor out an x squared out of these, okay, I'm just dividing both of these by x squared. Here we have left over an x, and here we just have left over a -1. So this is kind of our key. We're looking for this in our second part, and if we get this in our second part, then everything's good. So looking at this second part, what factor do they share? Well, this has an x, but that doesn't have an x, so I can't factor out an x. But looking at the coefficients, this is a 4 and that's a 4. So I can pull out a +4. And what do I have left over when I divide everything here by 4? X minus 1. So that's good. So now I factor again because, right, this would be like x squared times y plus 4 times y. So I can pull that out from both, right? And when I remove that, what do we have left over? We have left over x squared plus 4. So this part, x cubed minus x squared plus 4x minus 4, became x minus 1 times x squared plus 4. So I'm just going to tag these on. As all of our factors, okay? Almost there. I'm going to rewrite it once in order. So here we still have, it's only two terms, but it's not a linear factor because you have that x squared. I have the x plus 2, and then I have x minus 1 twice. So I'm going to put x minus 1 squared just to, kind of save some space. So now we have to break down the x squared plus 4. Now there's two main ways you can do this. You can use the quadratic formula, right? Negative b plus or minus blah, blah, blah. But this is a special case because it is a quadratic binomial. So this I can set equal to 0. And I can just solve for x. I subtract 4 from both sides. I get x squared equals -4. Now this way we have to be careful because in this next step there's something that a lot of people forget. I want to get this x alone and it's tied up with an x squared. So I have to take the square root to get rid of that. In algebra, when we take the square root, you'll hear me say this over and over and over again, you have to put plus minus. Okay? If you don't put the plus minus, you only get one answer, and that wouldn't be enough. We'd only have 4 roots. All right, so now we want to simplify this. Well, the rule tells us we take out the imaginary number, I, and then we're left with the square root of 4. The square root of 4 is 2 times I. And then we still have the plus or minus there. Questions? Yeah, because I know we've talked about this, but we haven't, I don't know, we didn't really practice it. All right. You would get the same thing if you did, I'm going to put it up here real quick. So we have x squared plus 4. So our a is 1, our b is 0, and our c is 4. So if we did this formula, well, it would be 0 plus or minus 0 squared minus 4ac, so that would be why is that not matching up? Oh no, we're good. Negative 16 over 2. Right, so here the plus and minus is already there. So then this would be negative 4i, I'm sorry, plus or minus 4i over 2, which would give us plus or minus 2i. Okay, so those are both ways that we can do it. So our last step is just to rewrite everything as linear factors. Well, I have the x minus 1 squared. We have 2 of those. I have the x plus 2. And now I'm going to have x plus 2i and x minus 2i. And that is our final solution. All right, that was a bit of work. Now, if they asked you for all 5 zeros, right, you would just give me x equals 1, right, and we get that twice. So you could write that twice. X equals negative 2, x equals 2i, and x equals negative 2i. These two are swapped. That doesn't go with that. It's crisscross, but you get the idea. And everything that we've learned, right? 5 zeros. Our original function was to the 5th power, right? So everything matches up. Okay. So, all right, let me stop recording.